I'm going to be going over this really basic divisibility proof problem that may pop up on your discrete math midterm or final. Note the problem may look like this, and I will be skipping some steps or else this video would be way too long. So, the problem reads like this. For all integers a, b, and d, if d divides 3a plus 2b, and d divides 2a plus b, then d divides a and d divides b. So, by definition of divisibility, we know that 3a plus 2b equals d times some integer, I'm just going to say s, and 2a plus b equals d times some integer, I'm just going to say c, and now we have a linear system of equations. So notice how I can just multiply this equation by 2 and isolate a. So I'm going to do that. So I'm going to have 4a plus 2b equals 2dz. Now I'm going to subtract this by the first equation, 3a plus 2b equals ds. Now if I subtract these cancel out. I'm going to be left with a on the left side. A equals 2dz minus ds. Notice how I can just take out this d. So d 2z minus s equals a. And this shows that d divides a because d is a multiple of a. So now for the second part of the problem. Obviously, on an exam, you would not write it like this. You would write it way more neatly. But for the sake of this video, I'm going to write it like this. So we're going to start with our system of equations that we wrote down originally. And remember, this is because of the definition of divisibility. Okay, so now I want these a's to be equal so I can isolate b. So what I'm going to do is multiply the first equation by 2 and the second equation by 3. Now when I subtract these cancel, and I'm going to be left with b on the left side. And on the right side, I'm going to have 2ds minus 3dz. Now, again, I'm just going to take out the d, and I'm going to have 2s minus z. 3z, sorry, like so. So now this shows that d divides b